occurs to me that you can't see all my fancy footwork with the webcam where it is, but let's look now at what happens if we log y. Remember that if we're not logging, we do additive increases. So it should make sense that in this case, we're going to talk about an additive increase on x, but then how it causes a multiplicative effect on y. So we have here a log on y, but we want to talk about just y. So how do I get rid of a log? Well, I'm going to use this trick right here, where if I raise it to the power of whatever the base is, in this case, I chose base e because that's what r does. So if I raise everything here, and now that we have an exponent to something plus something else, we can use the property of splitting it, which is the same reason logs work this way. And it's worth noting what's happened to our y-intercept. Our y-intercept is not some value where it starts and then we add to it. Our y-intercept is now the base to that power of the y-intercept as a multiplicative start. So this model is a little bit more confusing. That's why we started with the other one first. But I want to compare what would happen to this, which is nothing more than the model we started with. But what if instead of x, I switch to using x plus 1? And I want to see what happens to that. And I want to get it in terms of the model I started with, but with some extra addition thanks to that plus 1 part. So I'm going to take this equation right here, and we're going to simplify it by distributing that beta 1 through the parentheses. And now, once again, I have an exponent to two things added together. So I can use the same trick we used here. And now you can see we have what we started with before, except it's multiplied by this extra e, which was the base we used on our log, raised to the power of our beta 1. Now, this guy right here is just a number, which is 1.07. So what does it mean to multiply by 1.07? It means we're multiplying by 1, which would just give us the model we had before, and also multiplying by 0.07 more, which means we can interpret this as each increase of x will have y increase by 7%. And you might say, hold on, what if I had used a different log here, like a log base 10? That would have changed this number to be whatever it needs to be to get the exact same value here. It really doesn't matter what log you use here, you'll end up with the same multiplicative effect of 7%, which in the context of this scenario is saying that every increase of temperature causes 7% more bacteria at the dump. Now, what makes this different than the elephants? The elephants, we were talking about adding food, but there were a lot of other factors limiting them within the Zambian country. And so giving more and more food, it had less and less effect because there were other things. But here we're assuming the bacteria have pretty much an endless supply of food. That's why I made it be at the dump. So here we have what the limiting factor is. As you loosen up on that limiting factor, the population explodes. If there's very little bacteria, then it would have little effect because 7% of a small amount is a small amount. But if there's lots of bacteria and the temperature goes up, then 7% of a lot is going to cause a huge boom in the amount of bacteria at the dump. So two different stories. The last video, we had something where more and more x caused this leveling off effect of the y. It didn't go up as much. Here we have y shooting up, which is why it's an exponential model. But you need all the math. The bottom line here is that if you have a log y on a linear form of x, then the base here, whether it's base e, base 10, or base whatever you want, you take that base, raise it to the beta 1, and then subtract it from 1 because that tells you how much it's increasing or decreasing from what we had before. And then to make that a percent, you got to times by 100 to be percent. We did it before, 0.07 became 7%. But this is really all you need. I hope by seeing the math, you'll understand that it's not nearly as complex as you wanted. If you had to, you could go back through the math. But let's go ahead and try the log model in the next video.